So in this last type of problem, we are going to be solving exponential inequalities. So in this case, you'll see you've got an exponential expression. You've got 3 to the x power, and that is less than 20. And we need to find what values of x are going to make this a true statement. So what we want to do here is we first want to go ahead and we need to get x out of our exponent right here. We want to get x by itself isolated so that we can see what the solution set will be equal to. Now, in this case, we need to undo this 3 base x. So we want to go ahead and if we take the log of both sides, that is actually going to allow us to cancel out this 3 and we'll get x by itself. Now, because 3 is our base, we want to go ahead and take the log base 3 of both sides. Because if we take the log base 3 of 3 to the x, the log and the 3 will cancel out and we'll be left with x by itself. But we also have to take the log base 3 of our right hand side too, because you have to take whatever you do to the left hand side, you do to the right hand side as well. So we get log base 3 of 3x is less than log base 3 of 20. As I said, the log base 3 and the 3 are going to cancel out, so we're going to get x is less than log base 3 of 20. Now we've just got, this is just a straightforward inequality. Log base 3 of 20, you can just plug into your calculator or you can use the change of base formula to get the exact value. Remember that we always want to round it to 3 decimal places. So if we take log base 3 of 20, that's going to give us roughly 2.727. So our solution would be x is less than 2.727. What that means is all x values less than 2.727 will make this a true statement if we plug them in. So at this point, I want you to give this problem right here a try. So 2 to the x is less than 36. Go ahead and solve. Write down your answer in the form of an inequality. So whatever your solution range is for x, go ahead and enter it into the text box now. For our next example, now that you've done that one, we've got log of x is less than or equal to 2. So the first inequality was an exponential inequality. Now we've got a log inequality. The steps are going to be pretty similar that you go through. What you need to do is you're going to have to undo this function that has your variable inside of it. So in the previous one, because we had 3 to the x power, we used log to undo our exponent. Here, because we're taking the log of x, we're going to have to use our exponential function to undo the log and isolate our x variable. So in this case, there's no base written down because it's our common log. So this is log base 10 of x is less than or equal to 2. What we're going to do is we're going to go ahead and take exponentiate both sides using base 10. So that's going to give us 10 to the log base 10 of x is less than or equal to 10 to the second power. Now again, the reason we did this using a base 10 was we need to have our exponent base and our log base equal so that they cancel out. So now on our left hand side, 10 to the log base 10 is going to cancel out. We're going to have x by itself. So x is going to be less than or equal to 100. Now, in this problem right here, before we just write this down as our final solution, we need to make sure that all of these values will work. Now, if you look at our original problem, we're just taking the log of x. Now, log of x is only defined if x is a positive number. So we can't just write x less than or equal to 100 as our answer. We have to specify that it is only positive numbers. So our inequality would be x is greater than 0 and less than or equal to 100. So this is how you solve this type of problem algebraically. You can also solve this graphically. but because we're not using graphing calculators, I'm not going to worry about going over that one with you right now. We will look in class at an example. We're going to look at the graphs of log of x, and we're going to see how we can solve an inequality like this using the graph approach when we have the graph in front of us. But we'll look at that in class. So right now, this only method that I want you to focus on is this algebraic approach to solving this. And to go ahead and practice that one, here's another problem for you. So solve the log of x less than or equal to 4. So again, go back if you need to, look at how we solved that problem, and you can go ahead and go through the same steps. Remember, there's no base here, but you know what the base of this log is. And go ahead and write your answer in the form of an inequality in the text box. And again, make sure to check if there's any part of your inequality that doesn't work, and make sure that your solution set only includes values that will be give us defined results.